Hi, topic for this session is pointer to array. We have already covered the basics of array and how arrays are stored in memory. So suppose we have an array int ARR5. So ARR is the starting address of the memory allocated to store 5 continuous integers. Right. So ARR, which is the name of the array, stores the starting address of the continuous memory allocated. Right. So let's see the first scenario. So in the first scenario, we have an array of 5 elements 1, 2, 3, 4, 5, and we have a pointer int star ptr, and we give the address. I told you the starting address of the array to ptr. Therefore, now ptr is pointing to the same continuous memory location allocated in the previous line. Right. Now we try to print ARR and PTR. So both these pointers are going to print the same address, which is the start address of the continuous memory allocated to store 5 elements of integer type. Right. The output is not sure, it depends upon the allocation methods in the memory handling of a particular PC in which we are running this program. Right. So let's move to the next scenario. Let's consider the next scenario. Let's move it step by step. Now in this scenario, we have the same array as declared in the previous scenario. 1, 2, 3, 4, 5 are the values, and 5 continuous memory locations of type integer is been declared, and then we have a pointer called ptr, which is storing the address of array, which in turn stores the address of the first memory of the array, first memory location of the array. Now when we are trying to print the elements in this array, if you could see that we are using the same methodology with normal array and with the pointer. That is the same brackets, same pattern, right? And we'll give the same output. So the output will be 4, because this is the fourth element, because we start the index value from 0 to n minus 1, right? So this will be the output 4 and 4. Let's move to the third scenario. In the third scenario, what we are doing is we are making a slight change to it in representation of the same thing. Right? We have same array, same pointer, same address of the array view, first address of the continuous memory allocation of an array being given to the pointer ptr, and we are printing the fourth element. But the way we are printing is we are printing in the form of a pointer. Now ARR has what? The first memory allocation. We add 3. Therefore, memory has been incremented by 3 into 4. 4 is what? The size of integer. So the address moves by 4 into 3, 12. So it's now pointing to the, we start from 0, it's pointing to the starting address of the fourth element. ARR plus 3 is the starting address of the fourth element or fourth integer in the array. And when we put a star, it gives the value at this address. Right? Similarly, it's happening in the case of the pointer. So these two are again same. Right, and we'll give the same output as we got in the previous scenario. If we go back on the previous scenario, just to show you, either we can write it in this way, ARR square brackets 3, PTR square bracket 3, or we can write it as star value at ARR plus 3 and star, that is value at PTR plus 3. It will give us the same output. Right, that is the fourth element in the array, which is 4. Let's move to the next scenario. Now in this scenario, there has been slight modification. We are also trying to print the address, just to confirm or just to be sure that they are actually going to the same memory location. So we have added couple of statements just to print the address ARR plus 3 and PTR plus 3, right, in the previous that we did in the previous couple of scenarios. So we are printing them, and you can see on the right hand side or bottom that is we have the same address. So when we do ARR plus 3 or PTR plus 3, it will take us to the same memory location, which is the starting address of the fourth element of the array, which has a continuous memory location, right? Okay, so let's move to the fifth scenario now. That is pointer to a 2D array. How we handle pointers in case of 2D array. Suppose ARR is a 2D array, right? ARR we know always stored the starting address of the continuous memory location, and memory is continuously allocated even in the case of 2D array. So the memory for the first row has been allocated, after that memory for the second row has been allocated, and after that the memory for the third row is allocated. So we have a single sequential continuous allocation of memory in case of 2D array. That is the basic concept, right? So now let's come back to the scenario. ARR is the 2D array. We can access any element as we usually do. We have done in case of 2D arrays, and also in case of matrices. ARR I and J. I is the number of row and J is the number of column, right? We can also do it by using the same pointer. ARR is pointer. That till now I think this should be clear that ARR is still an address. So we can also refer it in the form of pointers. We write star ARR plus I plus J. Now I is the number of row. So first we count the number of rows. You know, in a bracket, first internal bracket is solved, then we move to the outer bracket. So ARR plus I star, what it will do is it will go to the value at the first location of the second row of the array, which is in turn an address, and then we add J. J is the number of columns we need to shift to get to the desired location, right? J is the number of column. So we write ARR plus I star, that will give us the address of that particular row, which is in turn an address. We add that to the J, right? That will give us the column address, and then we put a star outside this. This is the star, which will give us the value at location I comma J, right? Therefore this statement, this ARRIJ and star ARR plus I plus J is going to print the same output. Now let's try and understand with the help of a code, right? We declare a 2D array of 3 into 3 by 4. There we have 3 rows and 4 columns, right? We try to print the address of ith array, that is first, second and third, right? The first row is going to print the same address by this or by this. These two are going to give us the same output, that is the address of the first element of each row. If you have a value of I is equal to 0, then the address of this 10, where this 10 is stored, and if the value of I is 1, then is going to tell us both things are going to give me the address of memory location where 20 is stored, and so on. And if you try to print the value, each of these value, then the I is representing the number of row. Therefore this ARRIJ that we did in the previous sessions, and this ARR plus I that we did in the previous slide, just to understand how this happens, plus J is going to give us the same output, that is the each value at each position in this array. This is number of rows 3, and this actually for loop is inside this loop, right? So that is going to give us all the values in this array. Is going to print all these values in this array. The value printed by this and this are same. Value printed by this and this are same. Let's see the output and we'll understand this. Okay. So for the first I is equal to 0, we have address of 0th row is equal to this. This is printed by first address in this 0 into 7 double F, and second both are printed. This first is printed with this AI, right, and this second of this 0 into X into 7 FF is printed by this, right. And in the second line, if you could see the output, this there are like 10, 11, 12, everything is been printed twice. First has been printed by this ARRIJ in square brackets, and second values is printed by this star star AR plus I plus J. This is how we can represent or use as an array as a combination, as a pointer, and we can handle the array in terms of pointers as well.